Here's something that'll mess with your brain. The world's first drone was built by the Nazis, and it flew completely on autopilot before computers even existed. I know what you're thinking. That's impossible, because when we think of drones today, we think cameras, GPS satellites, microprocessors running millions of calculations per second. But here's the kicker. In the 1940s, none of that existed. No transistors, no integrated circuits, no digital anything. Yet somehow, Nazi Germany created a machine that could fly itself 250 kilometers, maintain altitude, stay on course, and hit a target, using nothing but gears, springs, and compressed air. And honestly, when I first learned how it worked, I was more impressed than I was comfortable admitting. Today, I'm going to show you exactly how Hitler's engineers pulled off what should have been impossible. Because this isn't just a weird historical footnote. This is the grandfather of every cruise missile, every military drone, and yes, even that quadcopter your neighbor uses to spy on your backyard barbecues. So buckle up. We're about to reverse engineer a nightmare. Let's rewind to 1944. Germany is losing, and they know it. The Luftwaffe, Hitler's air force, is getting absolutely demolished. Allied fighters are shooting down German bombers faster than they can replace them. And here's the brutal math. Every bomber shot down means losing an entire train crew. Pilots took years to train, years Germany didn't have. So someone in the Reich Air Ministry had a dark, practical thought. What if we just don't put pilots in the planes? Now, unmanned aircraft weren't entirely new. The US had experimented with radio-controlled planes in World War I. But those were toys compared to what Germany needed. They needed something that could carry nearly a ton of explosives, fly faster than most fighters could intercept, and most importantly, navigate to a target on its own. No radio signals to jam. No operator needed. They needed a robot, a flying robot, built with 1940s technology. Enter the Fiesler Phi 103. You probably know it by its scarier name, the V1. The V stood for Virgil Tongue Swath, vengeance weapon, because nothing says we're winning quite like naming your weapons after revenge. The V1 was Hitler's answer to a problem he created. He'd picked a fight with the entire world and was running out of people to throw at it. So he threw robots instead. But here's where it gets interesting, because building a robot that can fly straight, that's actually not that hard. Building one that can fly exactly 250 kilometers and then know when to stop, that required some genuinely clever, terrifying engineering. And to understand how they did it, we need to talk about a question that should sound simple, but isn't. How does anything know where it is? Okay, quick thought experiment. Close your eyes right now. Actually, don't. You're watching a video. But imagine you close your eyes. Can you tell if you're tilting left or right? Yeah, probably. That's your inner ear doing its thing. Can you tell how high up you are? Also, yes. Though that's more about air pressure and your body's weird ability to sense it. Now here's the hard part. Can you tell exactly how far you've walked in a straight line while blindfolded? Nope. Humans are terrible at that. We need landmarks, or GPS, or at least the ability to count steps. The V1 had the same problem. It needed to know 3 things. Am I flying level? Orientation. How high am I? Altitude. How far have I gone? Distance. And it needed to know all of this with 0 external input. No GPS satellites. Those wouldn't exist for another 30 years. No radio guidance. Too easy to jam. No cameras. This was 1944, not 2024. So how did they solve it? With some of the most beautifully over-engineered mechanical systems ever crammed into a flying bomb. Let's break it down one problem at a time. Problem 1, staying level. First challenge, keeping the V1 from wobbling all over the sky like a drunk pigeon. Their solution? Gyroscopes. Now, if you've never played with a gyroscope, here's all you need to know. When something is spinning really, really fast, it really doesn't want to change direction. It's called angular momentum, and it's the same reason a spinning top stays upright. The V1 had 2 gyroscopes, one for pitch, nose up or down, one for roll, tilting side to side. These weren't digital sensors. They were literal metal wheels spinning at thousands of RPM on precision bearings. And here's the genius part. When the V1 started to tilt, the gyroscope would stay level, because physics, which would then mechanically push a control surface to correct the tilt. No computer, no calculation, just physics and mechanical linkages. It's like if you put a marble on a plate, and every time the plate tilted, a little robot arm automatically leveled it out. Except instead of a marble, it's a gyroscope. And instead of a plate, it's a bomb traveling 400 miles per hour. Problem 2. Maintaining altitude. Next problem. How do you know how high you are without looking out a window? Answer. Air pressure. The higher you go, the thinner the air, the lower the pressure. This is basic stuff. It's how altimeters work even today. The V1 used an Aneroid barometer, essentially a sealed metal capsule that expands or contracts based on air pressure. As the V1 climbed, the capsule would expand. Too high, the capsule would mechanically adjust the elevator to push the nose down. Too low, opposite. Basically, the V1 had a mechanical lung that would wheeze if it flew too high. Elegant and deeply unsettling. Problem 3. Knowing when to stop. Now here's the hardest part. The V1 needed to know when it had traveled exactly, let's say, 240 kilometers, so it could cut its engine and dive into London. How do you measure distance traveled without GPS? You count. The V1 had a small propeller on its nose, not for thrust, just for counting. As the V1 flew through the air, the wind would spin this propeller. And every rotation of that propeller turned a mechanical counter. Kind of like the odometer in an old car, except instead of measuring miles on a road, it's measuring miles in the sky. Before launch, a crew member would calculate how many propeller rotations equaled the distance to the target, and they'd set the counter to that number. When the counter hit 0, engine off, controls locked, gravity takes over. And that's it. That's how a machine with no brain knew when to fall out of the sky. All right, let's put this all together. Let's watch a V1 launch. Picture this. It's 3 a.m. in Nazi-occupied France. There's a long metal ramp pointing toward England, angled up at about 6 degrees. At the base of the ramp is a V1, sitting there like a miniature plane with stubby wings. But here's the thing, it doesn't have wheels. It can't take off like a normal plane. So how does it get airborne? They literally throw it into the sky. The ramp has a piston system underneath, powered by a chemical reaction. Basically, they mix two volatile substances that explode into steam, and that steam launches a piston down the track at insane speed. The piston is connected to the V1, and when it reaches the end of the ramp, the V1 is doing over 200 miles per hour. The piston stops. The V1 doesn't. It just yeets itself into the night sky. And for a moment, the crew on the ground watches this 25-foot metal dart scream into the darkness. Its pulse jet engine roaring like a chainsaw from hell. That engine, by the way, is another masterpiece of terrifying simplicity. It's called a pulse jet, and it works by repeatedly exploding fuel in a tube 50 times per second. No moving parts in the engine itself, just controlled explosions pushing the V1 forward. It sounds like a lawnmower having a panic attack. The British called it the buzz bomb because of that noise. And here's the horrifying part. Londoners learned that as long as they could hear the buzzing, they were safe. Because the V1 was still flying. It was when the sound stopped that you ran. Because that meant the engine had cut out. The counter had hit 0. And somewhere within a half-mile radius, a ton of explosives was about to ruin someone's day. Let's talk about what it was like to live in London in 1944. The Blitz, the sustained bombing campaign of 1940 to 41, was over. People had started to feel like maybe the worst was behind them. And then, in June 1944, the V1 attacks began. Here's the thing about the V1 that made it psychologically brutal. It was random. A regular bombing raid. You could hear the planes coming. You could hide. You had some sense of control. But the V1, it could come anytime, day or night. No warning. Just that sound. That mechanical buzzing, getting louder, and then silence. People described a specific kind of dread. You'd hear the buzz, and you'd freeze. Everyone around you would freeze. And you'd all just listen. waiting to hear if the engine cut out overhead. If it kept going, you'd breathe again. Someone else's problem. If it stopped, imagine that. Imagine that being your daily life for months. Over 9,000 V1s were launched at England. About 2,400 hit London. Each one carried 1,800 pounds of explosives. The death toll was over 6,000 people. Another 18,000 seriously injured. And here's maybe the most disturbing part. The people launching these things had no idea where they'd land. They could aim in the general direction of London, but once that counter was set and the V1 was in the air, it was up to wind, weather, and mechanical tolerances. One hit a church during morning service. Another hit a school. These weren't precision strikes. They were mechanical roulette. But Londoners, being Londoners, adapted. They made jokes. They gave the V1 nicknames Buzzbomb, Doodlebug, Robot. Kids would collect shrapnel like trading cards. And the British military? They got creative. So you're Britain. You've got these robot bombs flying at you at 400 miles per hour, and you need to stop them. What do? Well, you got a few options, and the British tried all of them. Option 1, shoot them down. Easier said than done. The V1 was small, fast, and flew low, about 2,000 to 3,000 feet. Anti-aircraft guns could hit them, but you needed a lot of shells and a lot of luck. The British moved hundreds of AA guns to the coast and equipped them with proximity fuses, shells that would explode near the target, not just on direct impact. This worked sometimes. They'd shoot down maybe 1 in 4. Option 2, intercept with fighters. This was harder than it sounds. The V1 flew at nearly 400 miles per hour. In 1944, that was faster than a lot of fighters, especially at low altitude where the air is thicker. Only the newest, fastest planes could catch them. Spitfire XIVs, Tempests, Mosquitoes. And even then, shooting one down was risky. If you hit the warhead just right, it could explode and take you with it. So some pilots got creative. They figured out that if you flew alongside the V1 and gently tipped its wing with yours, you could flip it off course. The gyroscopes would freak out, the V1 would lose stability, and it'd crash into the English Channel. Imagine doing that. Imagine flying 400 miles per hour 10 feet away from flying bomb, trying to nudge it with your wingtip without blowing yourself up. Some British pilots did this dozens of times. Absolute madmen. Option 3, barrage balloons. This one's almost comical. The British floated hundreds of hydrogen balloons over London with steel cables hanging from them. The idea was that a V1 would fly into the cable, get tangled, and crash. And you know what? It worked. Kind of. They caught about 300 V1s this way. Of course, they also occasionally caught their own planes, but hey, war is messy. Okay, so the V1 sounds terrifying, and it was, but it also had some major flaws. First, accuracy, or lack thereof. That little nose, propeller, counting distance, great in theory, but if there was a headwind, it would spin faster, and the V1 would think it had traveled farther than it actually had. Tailwind? Opposite problem. Wind could throw off a V1 by several miles, which, if you're aiming at a city, might still hit something, but if you're trying to hit, say, a specific factory, forget it. Second, the gyroscopes were sensitive. Any damage during launch, a crack, a misalignment, and the V1 would just spiral off course. A lot of them crashed into the English Channel because they wobbled out of control 30 seconds after launch. Third, they were expensive. Each V1 cost about 5,000 Reichsmarks, roughly the price of a small car in 1940s Germany. And remember, these were one-use weapons. Every single one was destroyed on impact. Compare that to a regular bomb, which you could drop from a plane and reuse the plane. The V1 was basically a very elaborate way to throw money at England. Not great economics when you're already losing a war. But here's the thing. Despite all these flaws, the V1 worked well enough to terrify an entire nation. And more importantly, it proved a concept. So here's the part that'll really mess with your head. The V1 failed. Nazi Germany lost the war. The V1 didn't change the outcome. It didn't break British morale. It didn't destroy enough infrastructure to matter strategically. But the technology didn't die. After the war, both the Americans and the Soviets grabbed every V1 blueprint they could find. They studied them, reverse engineered them, and then they built their own. The American JB-2 Loon was basically a copy-paste of the V1. The Soviets built the KS-1 Comet, same idea, better engine. And those designs evolved into the first cruise missiles. The BGM-109 Tomahawk, which the US still uses today. Its great-great-grandfather is the V1. And it's not just military tech. The core concept, a machine that can navigate using internal sensors without external input. That's the foundation of every autonomous vehicle, every autopilot system, every GPS-free navigation tool. The gyroscopes are now electronic. The barometer is now a digital sensor. The propeller counter is now an accelerometer. But the principle is the same. So yeah, modern drones, in a very real sense, are descendants of Hitler's robot bomb. Which brings us to an uncomfortable truth. A lot of the technology we use today has roots in some pretty dark places. The internet came from military research. Rocket science came from Nazi engineers. Microwaves came from radar. Progress is messy, and history doesn't care about good guys and bad guys. It cares about what works. The V1 worked, not well enough to win a war, but well enough to prove that machines could fly themselves. And once that door was opened, there was no closing it. So next time you see a drone flying around, or you read about a cruise missile strike, or you let your car's autopilot take over for a few seconds, remember, that technology didn't start in Silicon Valley. It started on a metal ramp in occupied France, powered by steam and desperation. History is weird like that. Thanks for watching. If this broke your brain even a little bit, hit that like button. And let me know in the comments, what other impossible old technology should I cover next? See you in the next one.